All right, my BC kids, I want you to take a moment before we start this video and get up and stretch and do a little happy dance with your happy feet, because this is the last section of BC Calc. Oh, I'm getting all teary-eyed because this is the last thing I'm going to teach you in the last 3.5 years that I've had you. This is the last lesson. Oh well. You guys are going to go on and do great things, and you can always shoot me an email sometime later in life. Let me know what you're up to. But here goes the last section of BC that I need to tell you about. And it's all about finding the length of an arc. This is a short one. This one's not one that should take us much time to do. There's a formula to figure out what the length of an arc is. So if I want to go between 2 points, an alpha point, and I don't know that I want to mess up their picture here, but if I want to figure out the length of an arc, so let's say like one of these swirly whirly guys, they're kind of fun. I'll go this way with it since I started in that direction. If I want to know just what it is for the length of an arc going from here maybe to here, and I'm going to call this alpha, he's like the fish, and call this guy beta, I can figure out the length of that arc using a formula. Now, they derived the formula, and we're not going to take the time to do that. You just need to know the formula. So here's what the formula is. It's down here at the bottom of the page. By the way, on what I uploaded onto our classroom page, it shows the whole derivation of it. So if you're interested in how this formula comes about, absolutely it is there for you to peruse. But because we're on a time crunch and such, I just need you to know the formula. Okay, so here's what it is right here. This is the guy, the length of the arc, and I feel like we've definitely seen this before, is the integral from alpha to beta of the big old square root of r squared plus the derivative of r squared with respect to theta. That's it. That's the whole formula. That's it. All right, so let's do it. Find the length of the curve when r equals 2 minus 2 cosine of theta from the interval from 0 to 2 pi. So I kind of like these because they pretty much tell you your interval all the time. The only thing I've got to figure out is what is dr over dt. Sometimes we call that r prime. They're kind of one and the same deal. All right, well, what is it? Derivative of 2 is 0. The derivative of negative 2 cosine of theta is going to be a negative sign for this, which turns this into a positive. So it's going to be a 2 sine of theta. That's all you need, and then you can put the length together. The length is the integral from 0 to 2 pi, alpha and beta, of a big old square root of r squared, what's r? 2 minus 2 cosine of theta, you tell me, plus the derivative of r squared, 2 sine of theta squared, and then that is with respect to theta, but with respect to theta is not part of your square root. So make sure you're not putting it under that root sign. So go to your handy dandy calculator, put that in, you get an answer of 16. That's the length of that curve between 0 and 2 pi. All right, here comes the next one. There's only one more example, I think. Yep. Find the length of the curve r equals 2 cosine of theta over the interval from negative pi over 2 to positive pi over 2. And you say, easy peasy, lemon squeezy, let me find r prime. Well, if it's 2 cosine of theta, that's going to be 2 sine of theta, but remember it's going to be negative. All right, got my pieces. Let me get my length. I am this time going negative pi over 2 to positive pi over 2, and I have to take a big old square root. I'm looking at my notes that I took over here. Look at when I was doing my example. What did I forget? You forgot the big old square root. There it is. Okay, big old square root. And I want r squared, so 2 cosine of theta squared plus r prime squared, so negative 2 sine of theta squared, and then d theta is outside of that. Go to your handy dandy calculator and say, pretty please tell me the length, and he says to you 6.283, and you say thank you very much. That's the arc length formula. There's really not, how many more examples do you want, right? So let me show you what happens with the H-dubs. The H-dubs for this one, you are not doing anything on this front page. Now you can if you want, and I did include the answers for this, but these go back and review things that we learned about with polars and rectangular coordinates and converting between the two, finding slopes. It also goes into finding the area of a region of these loops like we did back in section 17.2. So I do not want you to do this. All you're doing, and I put the little bubble here, is completing number 6 and 7. So number 6 and 7, they are a couple parts each. 6 is directly applying this length formula, the arc length formula, and 7 gets into a little bit of review stuff. So 6 and 7 are your questions. Those are posted on our classroom page for you to do. Also posted are, like I said, this is the derivation of the arc length formula if you're interested in that, along with answers to all the things that I told you to skip. So if you do want to do those problems, the answers are posted and you've got them for you. But the ones that really apply to the lesson are number 6 and 7. All right, then you're working on the mastery check and then you're done. All right, we did such a good job. You guys are awesome. And we're going to ace this test. I'm confident in you. And I'll see you in class. Shoot me an email if you have questions.